Welcome to our Chapter 2, Descriptive Statistics. In this chapter, we learn how to take a bunch of raw numbers and turn them into something meaningful. You see how we can organize data by using different type of graphs and describe the data by using just a few simple summary measures. We also learn how to recognize patterns, compare data values across datasets, and spot unusual results. By the end, you'll be able to take almost any dataset and tell its story clearly, which is a very useful skill in work and everyday life. So let's start on. So in this chapter, we'll cover three big tools. So first, we learn how to use tables to organize data. And then we learn how we can use different type of graphs to visualize the data. And last, we will learn how to use different numbers to summarize the data. So together, they are the main building blocks of descriptive statistics. So let's first look at how we use table to organize data. So for frequency, the table we often use is called frequency table, frequency distribution. And from now on, we just use the term FREQ here to represent for the frequency, okay, to save space for our slide. So this is just a way we use, the table to summarize data, to make the data more well organized, especially when you have a lot of raw data, right? So in this table, we will partition the data in several classes, and then we tally the values of the data in each class, and then put the frequency and list the frequency in each class. We have other modified versions like relative frequency, where we don't use the frequency number, but we use the relative number, which is that frequency divided by a total. The percentage, which you translate the relative to the percent. You also have the cumulative version. And we will find out this table in next couple of slides. So let's look at an example about the disk length of 30 guinea pigs. So this is the real data where people, they do the experiment, try different kind of toothpaste on the guinea pigs, and then after a couple of weeks, they measure their teeth length in millimeter here. So here we have 30 guinea pigs. The teeth lengths are 4.2, 11.5, 7.3, 5.8, and so on, so till 29.5. So you can see that here, if you just look at the raw data as a whole, it will be very messy. And imagine like now, if we don't have 30 guinea pigs, but we have maybe 30,000 or something like that. And for sure, we don't want to look at the raw data, right? It won't tell us much. So here, we can use the frequency distribution, frequency table, to represent the data. So what we do is that we will divide, partition the data set in 4 different classes, from 0 to 9.9, 10 to 15.9, and then 20 to 29.9, and 30 to 39.9. So basically, the whole range here, it will cover all the values of the disk length here. And then we start to tally the value belong to each class here. So for example, like for this tooth length from 0 to 9.9, we have 7. So let's check. 1, 2, 3, 4, 5, 6. Okay, what else? 7 here, right? So 7. And the same you can do for the class from 10 to 19.9. You get 13. The 20 to 29.9, you get 8. And the 30 to 39.9, you get 2. So 30 to 39.9, we check one more. Okay. So we have here 33.9, and we have 32.5, right? So we have two guinea pigs with this tooth length. So you can see from a messy data like this, right? Raw data like this, we can make it in a very well organized way by using this table. And the same thing we can do, say, even you have like 30,000 guinea pigs, or maybe say 3 millions, right? You can do the same thing. So how we can build this frequency table and what are the terminologies and people use, and when look at the frequency table. So here we have the term lower upper class limits. So basically, it's just the smallest or largest number belong to each class. So here we have like you can see the lower here for this class is 0, upper here is 9.9. For this class, the lower is 10, upper 19.9, right? The class midpoint, basically we just use upper plus lower divided by 2. So it's just the number is represent for the class, right? So if I have to choose one number, so natural kind of talk is just use the lower plus the upper divided by 2. So for this case, about 4.95, you just use 0 plus 9.9 divided by 2, right? And the same thing here, it will be 14.95 and so on. We have a class boundaries. This is numbers used to separate the class, but without the gaps. Okay, so here the formula to calculate that. For the lower bound, it's just your lower limit. Subtract k by 2. Upper bound equal to upper class limit plus k by 2 and k the gap. So for this here, you can see if you look at this table, right? We have a gap. So from this class 0.99 and this class 10, 19.9. We have a gap between 9.9 to 10, right? And then we represent in the chart. We want it to, we don't want the gap. So the gap here basically is just the k, which is the gap here is just 0.1, right? You jump, you see 9.9 jump to 10, so the gap is 0.1 here. And so basically, in order to make to fill the gap, we will use the class boundary instead. And for example, for this for the first class, right? So if we look at we can calculate the lower bound for the first class and the upper bound for the first class. So in this case, like if we use lower bound, subtract by k by 2, so you have 0 subtract 0.1 divided by 2, and you get a negative 0.005. But because this length is non-negative, right? So you can keep 0, or you can also use a negative value. It doesn't matter, but often people they will use the 0 as a lower cutoff here for this case. But for the upper one, it will be the upper, right, plus k by 2, upper plus k by 2. So upper limit here is 9.9 and k 0.1 and divided by 2, so you get like 9.95, right, 9.95. And you do the same thing here. The lower will be 10 subtract k by 2, so you go down to 9.95, right? So from here you can see the matching that happened, right? So here the upper will be upper boundary will be 9.95, and here you go down, you got 9.95. Same thing, the upper it will move up a little bit to 19.95, and also here the lower will be 20 subtract 0.1 by 2, you get 19.95, so which is matching, right? Matching, and you no longer have the gap when you look at the class boundary. The class width is just a distance between any two consecutive lower class limits. Okay, you can also use like upper bound subtract lower bound. So here you have to be very careful. Okay, a lot of people make mistake when calculate class width by using the upper class limit subtract to low class limit. Okay, and it will not match with the definition. And a lot of time, if the multiple choice question, you make a wrong choice, right? So it has to be two consecutive, right? Lower class. So this one, 10 and 0. So the class width will be 10 subtract 0, right? Maybe you can also use 20 subtract 10, which is 10, right? 30 subtract 20, right? Which is 10. You can also use two consecutive upper limit as well. So 19.9 subtract 9.9, 29.9 subtract 19.9, right?
39.9 subtract 29.9. It all give you 10, right? Don't use the upper limit, subtract the lower limits, because it will give you the 9.9, which is the wrong answer. Wrong answer. So remember, distance between any two consecutive lower class limit. Okay. You can also use upper boundary, subtract lower boundary. So if you after you calculate the boundary, for example, for this guy, let's use something in the middle here, which is 9.95 to 19.95. So you subtract them together and you get 10, right? Value 10. So here again, we just discuss, we just have all these value in this slides, right? We just discussed about that. We have 5 classes, 0 to 9.9, 10 to 19.9, 20 to 29.9, and 30 to 39.9, right? 39.9. And lower class limit, we have 0, 10, 20, 30. Upper class limit, we have 9.9, 19.9, 29.9, 39.9. Again, class width, which is 10, right? You can calculate in different way. Class midpoint, just the representative for each class, right? Gap, which is, here we have a gap, right? 9.9 to 10. The gap is k equal to 0.1. Here we have a gap here. Here we have a gap here. They're all 0.1, right? And the boundary, the same, right? You can get the low boundary for this class is 9.95, upper is 19.95. So basically, you use lower, you subtract the k, which is 0.1 in this case, and equal to 2. So here the quiz, and I think a little bit, think about it a little bit. We have the tooth length data, right? So find the class boundaries for the class 20 to 29.9 in the per frequency table. Okay, find the class boundaries for the class. So how we do with how we can work on this question, right? So first of all, we need to look at definition again. What are class boundaries, right? So a class boundary, here for each class, the lower boundary will be lower limit subtract k by 2. Upper boundary will be upper limit plus k by 2, right? So in this case, we know that the k is 0.1, right? K is 0.1 because it's a gap, 0.1. The gap, right? From 9.9 to 10, you get a gap, right? The gap is 0.1, right? Similarly, maybe from 19.9 to 20, right? The same, right? And so on. So basically, for the class 20 to 29.9, the lower limit will be 20, right? Upper would be 29.9, right? So from that, you can get the lower boundary, lower bound, equal to the lower, which is 20, subtract k by 2, right? And you get 19.95. And you can also get the upper bound equal to 29.9 plus k by 2, right? 1 by 2, and you get 29.95. So this is how you find the class boundary. So the class boundary for this class would be from 19.95 to 29.95. So how we can construct a frequency distribution? So basically, like there are several steps here we can work on. First, we call step 1, which is subjective choices. So in this case, first you need to choose number of classes. So it depends on, the story you want to tell, right? But often, typically, people choose from 4 to 12 classes. You don't want too many classes because sometimes it just distracts the audience, right? But also, you also don't want to have just the number of classes too small, right? So for sure, you don't want one class, right? Because one class is just all the data and it doesn't tell you much, right? Except for the mean, the max, and how many data points. So typically, people will go with 4 to 12, okay? With 12. And then after that, they would decide what the class width they want to use. So how to calculate that? They just, use the maximum value of the data, subtract the minimum, and divide by number of classes, which is they just decided, right? So for example, if they want 5 classes, and then number of classes will be 5. I say they want to use 6 classes, and then number of classes will be 6. So class width can be any number bigger than that max subtract min divided by number of class. But for sure, you also don't want to make it too big, right? Because if it's too big, and then it will be not informative. And then from that, you also choose the first lower class limit. So this value has to be at least the minimum value, right? At least the minimum value, to ensure your table will cover everything, And then after you get this all, nailed down, number of classes, class width, and first lower class limit, and then you start to build your frequency distribution. By first, you use the first lower class limit, and you just add up, right? Add up the class width to recover all the lower class limits for each class. And from that, you also get the upper class limits, right? After you get a lower, and you can also recover the upper class limit for each class, right? And after you have each class, what the value for each class, and then you just tally, right? So count how many value belong to each class, and then you get a table. So let's look at how actually this table will construct the given big data table here. So here we choose like 4 classes. We choose the class width is 10. Why we choose this number? Because we see that the maximum is 33.9, right? Maximum of the disk length and quality data set is 33.9, which is this value, right? And the minimum is 4.2 here, right? And so from that, you just, choose it, right? Divide by 4, which is number of classes, you just nail down. And you got 7.425. So the class we can be any number, right? Bigger than this number. But you want it to be 10 here, okay, to make 10 look neat, right? And then the lowest class here, just any number less than the mean, which is 4.2 here. So here we choose 0. You can choose 3, 4, or whatever number you want, right? But it has to be less than or equal to the mean value. But here we choose 0 here. So after that, you see we have a lower class limits. The lowest class is 0, right? So you just add up 10 to get all the lower class limits. So 0, 10, 20, 30. So you have all the lower class limit here. And after you have the lower class limit, right? Basically here, right? 0, 20, and 30. And then you recover the upper class limit, right? So say you can go with 9, right? 9.9, right? 9.9 to make sure, because we have decimal here, one decimal here. So the next guy will be before the 10 will be 9.9, a little bit smaller. Yeah, because if we choose 9 here, and then there's probably some value will not be covered in your class, right? Maybe say, what if I have a 9.5 and 9.6, right? And this won't be belong to, it will not belong to 0 to 99. It also not belong to this second one. So we don't want that to happen. So it depends on the nature of your data. You can move, you have to make it a little bit flexible to make sure you cover all the data values, right? So because this guy is 9.9, right? So this guy will be, you just add up 10, right? 19.9, 29.9, and 39.9. So from that, you can see that you get 4 classes, right? Which is on the left-hand side of the table. And then you start to tally to see how many values belong to the 0 to 9.9, how many values belong to the 10 to 9.9, and so on, right? And from that, you get a table. And the good news is that, often, the software, maybe Excel, different software like R, Python, it will do it for you. And with just one very quick function, right? So here is a modified version. Sometimes people they use. For example, they can look at, say, the frequency distribution, which is the original version we got here on the left-hand side here. You can also do the percentage frequency, which is, what we do is that we use the frequency value, we divide by the total. In this case, it's 30, right? 30. And you times 100%. This is you got like 23% for the guinea pigs with the tooth length belong to this class. And then the same thing, right? 13 divided by 30 in time 100%, you got this percentage. You got here 26.7% and 6.7%. So this is called the percentage frequency table. You also have another modified version called cumulative frequency table. Cumulative, yeah, right, cumulative. Okay, cumulative frequency distribution. So in this case, basically, like you can see, like everything from 9.9 and below, you have 7, right? And then you add up another class here. So basically, these two classes, if you add up everything below 19.9, right? So you put a 19.9 here, and just add up, right? Cumulative. And then you got like and you got like add up 3 classes here, right? You have everything less than 29.9, right? So in this case, you have like 7, 13, and 8. You got 28 in total. And everything from 39.9, which is all the data in this table, right? So you got 30 value. So this is called cumulative frequency distribution. And basically, this help in a sense, we see how things add up, right? So from here, you can see that pretty much like most of the data point, right? It kind of add up by 29.9, right? There are a little bit left over for the next chunk, right? About 2 data point, which is 6%. 6%. So let us look at quiz 2.2 here. So here the age is of 26 voters. We have 43, 56, 28, and so on, okay? And use the data to fill in the frequency table. So this is a table here. It's got a little bit modified by combining. We have a frequency and we have a relative frequency here. So here, like how we do that, right? So first, we look at the column frequency. So the column frequency here, just the tally, right? What we need to do is that we need to tally, see all the values, right, belong to each class. So the good thing here is that we already have the class partition for us already, so we don't need to do with all the construction like we just saw with the guinea pig data previously. So now how many value, which is how many voter between 20 to 29, right? So we just check it, right? 20 to 29, we have 1 here. We have 2 here. 3. That's it, right? 3. The first is 3. 30 to 39, we got 1, 2, 3, 4, 4, right? 4. 40 to 49, we got 1, 2, 3, 4, 5, 6, right? 6. 50 to 59, we got 1, 2, 3, 4, 5, 6, right? 6. And 60 to 69, we got 1, 2, 3, 4, 5, 6, 7. And 7. Okay, so let's see. 3, 4, 7, 7, 6, 13, 13, 19, 19, 7, 26, right? 26, which is total. So for our relative frequency, what we need to do, basically, we need just divide by total, right? With 3 divided by 26 here. you can use the calculator to calculate, right? What the decimal is. But that's fine if you just leave at at the fraction here as well. 26, right? And 7/26. Okay. So after that, we can also calculate it, right? By using the TI calculator. So here one page, I think you can use the TI calculator online. It's tical.com /ti84cal here. So what you need to do is just put in the number, right? You have 3 divided by, let me just make it's small a little bit. Okay, so first this way we can see it easier, right? 3 divided by, 3 divided by 26, right? And you got, which is in this case 0.115, right? 0.15 if you keep 3 digits. Okay. Be 0.115. You can also do the same thing, right? For 4 divided by 26, 41/26, which is 4 divided by 26, right? You got 154. 154. Okay, and so on, okay? And you can calculate for other values as well.